I welcome you all to the lecture annotation video on network model. You are familiar with the concept of network model, how it works. It represents how we transfer message in data communication. And let's go into the topic further. In this lecture, we will see the TCP/IP model. Before that, we will have a summary of the layers that were present in the OSI model, Open Systems Interconnections. At first, we start with the bottom layer, physical layer. What does it do? It transmits bits over the medium, the physical medium or the transmission medium, and provide mechanical and electrical specifications. That is what will be the topology, what will be the arrangement of the circuits, etc. Physically, it is performed in the physical layer. What does data link layer do? It organizes bits into frames and provide the hop-to-hop delivery. And what does this network layer do? It performs or moves packet from source to destination and provide internetworking. It provides the hops that we will need to jump so that the packets move from source to the destination. And in this case, in the case of transport, we have they provide reliable process to process message delivery and error recovery. Data link layer, from data link layer to above, all layers kind of performs this error control or flow control, but it is the specific task of transport to provide these error recovery mechanisms. In the session layer, it establishes, manage and terminate sessions. The session in which we communicate for a duration of time is maintained by this session. And in the presentation layer, we help to translate, encrypt and compress the data so that the data remains secure and the representation of the message becomes visible. And for the security and the reliability purpose, we compress the data so that it might travel very easily in the transmission media. In the application layer, the topmost layer of the OSI model, it allows access to network resources. That is what we are doing in the application layer is to perform the access via some software and hardware to the network resources. And these are the summary. Of the OSI model. Now we will go into the topic further. Now to mention that The TCP/IP protocol do not exactly match the OSI model. The original TCP/IP protocol suite was defined as having 4 layers. What are those layers? Host to network, internet, transport, and application. However, TCP/IP is compared to OSI model, and we can say that TCP/IP protocol suite is made of 5 layers: physical, data link, network, transport, and application. Now let's move into the comparison directly. Here we can see this. I'm marking the layers. These are the 7 layer of the OSI model, and the layer in the right portion is the TCP/IP model layers. We have 4 layers: applications, transport, internet, internetworking protocol layer, and protocols defined by the underlying networks or host to network layer that we have seen in the previous slides. The description you have to study from the book. I will give the book pages in your live lecture in the Google Meet, so do not worry. Now let's move on further topics. The basic difference between TCP/IP and OSI model. Now you might wonder why the name is not a difference here, because we do not maintain the name as being a good difference. The difference should be in the working procedure and the structure, and that is what we focus on in here. Number one, OSI is a generic protocol independent standard acting as a communication gateway between the network and end user. And TCP/IP model is based on standard protocols, whereas the OSI model was protocol independent. But TCP/IP is based on the standard protocols which Internet has developed. It is a communication protocol which allows connection of hosts over a network. So there is the basic difference, because one is protocol independent and another is protocol dependent on protocol, which allows the host to be connected in a network. And in the second point, we have the OSI model transport layer guarantees the delivery of packets, where in the TCP/IP model, it does not guarantee delivery, but still we maintain that TCP/IP model is more reliable. It follows a vertical approach and TCP/IP follows horizontal approach. It is kind of that OSI model passes the message from the sender to receiver in a vertical approach. And for the TCP/IP model, it goes or connects layer to layer, kind of like this. So it is called horizontal approach. And in the next point, OSI model has a separate presentation and session layer. Because it has well-defined functions for these two layers. And the TCP/IP does not separate this layer, but incorporates with the application layer that we have seen in the previous slide picture of the structure of TCP/IP model. Connection layer, transport layer in OSI model is connection oriented. That is, it depends on the connection, the type of the connection that is provided for the transport layer. But in TCP/IP model, the transport layer can be connection oriented and connectionless. And now in the next topic, the network layer. We have network layer can be both connection oriented and connectionless, and the TCP/IP is connectionless. What do we mean by these terms, connection oriented and connectionless? We need to establish a connection in order to exchange or communicate the data. Before that, we cannot fruitfully transmit the data and receive the data. In the OSI is a reference model which the networks are built. Generally, it used as a guidance tool. TCP/IP model is in a way implementation of the OSI model. OSI model is a kind of theoretical concept. Nowadays, we are trying to implement this model, but TCP/IP model is the more practical model. And in the next topic, network layer of OSI model provides both connection-oriented and connectionless service. That is already given in the sixth topic. It is kind of similar, so you need to write only one difference, not both of them. And in the OSI model, in the next topic, the OSI model has a problem of fitting the protocols into the model. As it is a kind of theoretical concept, it is very hard to fit the protocols in the model, the laws and the rules governing the data communication. We call them protocols. You already know that. But the TCP/IP model does not fit any protocol. Protocols are hidden in the OSI model and are easily replaced as the technology changes. As it is kind of very flexible in the OSI model, and it is hidden from the user interaction, it can be easily replaced as the technology changes. And in the TCP/IP, these protocols are fixed and this changing is not easy. It is not flexible at all. In the OSI model defines service interfaces and protocols very clearly and makes clear distinction between them. It is protocol independent. As we have seen, as we have declared earlier, OSI model defines, and it is very flexible, defines the services, interfaces and protocols very clearly, and the distinction between them is very clear. And it is also called protocol independent. It does not depend on the protocol. But in TCP/IP, the services, interfaces, and protocols are really not that clearly separated, and it is very rigid and very protocol dependent. And we all know this basic thing. OSI model has 7 layers, and TCP/IP model has 4 layers. And that is the and this whole is the difference between the TCP/IP and OSI model. Now let's move on to the next slide. Addressing. These types of address, we use them in TCP/IP for the protocols: physical, logical, port, and specific address. So let's move on to the topic. These are the classification of the addresses that we use in TCP/IP. What is the physical address? Physical address is the link address. The other name of the physical address is the link address. It is the address of the node defined by the connecting LAN or WAN. When we decide to use LAN for our networking purpose or WAN, we use a physical address or link address, and this size and format of these addresses may vary depending on the network. For example, Ethernet uses 6-byte 48-bit physical address. Physical address can be either unicast, broadcast, or multicast. Unicast is having one recipient, multicast is having a group of recipients, and broadcast is received by all systems in the network. So when we transmit or send a data, we need to fix a physical address of the recipient, whether it is a unicast, multicast, or broadcast message. We need to fix the address for the destination location, and that is how the physical address is being used in the TCP/IP model. And in the example, we have that there is a 48-bit or 6-byte physical address written as 12 hexadecimal digits. Every byte, 2 hexadecimal digit is separated by a colon, as shown in this address. For an example, a 6-byte 12 hexadecimal digit and these are the 12 hexadecimal digits: 7, 1, 2, 1, 2C, 4B, etc. Now let's move on to the next topic: logical address. What do we mean by logical address? Logical addresses are used by the networking software to allow packets to be independent of the physical connection of the network. that that is to work with different network topologies and types of media. The logical address in the internet is currently a 32-bit or 128-bit address that can uniquely identify a host connected to the internet. For example, we are connected to the internet by our laptop or mobile devices. Now we always have a internet address IP. This version is 4, and the decimal number is a group of four numbers that are required to be the address. And we have to be careful because no two publicly addressed and visible hosts in the internet can have the same IP address. The physical address will change from hop to hop because when we transfer a data from a end user 1 to a switching device or router R and then to the destination, this difference so first hop we give the address, the physical address or the logical address of the router, and then in the next hop we give the physical address or the logical address of the destination. The logical address remains the same, but the physical address varies from hop to hop. And these are the basic differences between them: the logical address and the physical address. The logical address can be either unicast, multicast or broadcast like that of physical address, but there are limitations on broadcast addresses for the logical address, because if we want to send a message to everyone that is who are connected in the internet, it is not possible. So this is the limitation of on broadcast address. Now let's move on to the next topic, port address. There are many applications running on the computer. Each applications run with a port number logically on the computer. For example, if we are using Google Chrome to access the meeting, the Google Chrome is an application that is being run on the computer and which has a specific port number to be identified by the computer. You should see a example in your operating system class about this, how this port address actually works. You should get a clearer picture in the operating system course. And the port number is a part of the addressing information we use to identify the senders and receivers of messages. So when we do chat in Facebook or in Google Meet, we use this port number to specify where the input or output should be shown. That is, if we use this Google Meet chat, the port number is different from the chat in the or messenger in the Facebook. So this addressing mechanism is very important. This port number allow different applications on the same computer to share network resources simultaneously. So if we are maintaining a video chat simultaneously in the Facebook and in Google Meet, we can use the port numbers and that they use for the microphones and the video cameras or webcams, and so that they can share the network resources at the same time. And this is the basic difference between port address and the physical address, because physical addresses change from hop to hop depending on the receiver of the next hop, but the logical and the port address remains the same. And port address is represented by a 16-bit address, and which is a decimal number, which is always a decimal number. And this is all about port address. Now let us move on to the next address for specific address. Specific address is the very familiar one for all of us, because some applications have user-friendly address that are designed for the specific application. For example, this is the email address of our Narayan sir, our esteemed colleague, a veteran educator, and this is the URL of our university. It kind of changed nowadays because it is diu.edu.bd. And it redirects to the daffodilvarsity.edu.bd. The first defines the recipient of an email, that is, this is the email address, and the URL, the universal resource locator, is the web address of our university. So these are the specific address if we want to contact a single person or a entity in the internet. We use this specific address, and this is all about specific address. You should go through the exercises that is given at the end of the chapter, and if you have any questions regarding this topic, you should ask me in the Google Meet. Thank you all. See you all in the next lecture. That is all.